Okay, I want to talk about the Alex homework just in case some of us are still figuring some things out. Because I get a lot of people telling me I only get 3 attempts when you get more. So let me enter the student view. So now I see things how you see things. And I'm going to do something I don't do that often, intentionally get a lot of problems wrong. So let's go through assignment where it's easy to see I'm getting it wrong. 1.4, I'm going to start. Okay, at the top it says I'm at attempt 1 of 5, right? Can you memorize these numbers? U plus 7 times U minus 6. Do you have those memorized? All right, what's U plus 7 times U minus 6? Is it 4? What? No, definitely not. There's definitely a U squared there. Okay, so I got it wrong. Let's try again. Is it 2? Yes, okay. All right, I got it wrong. It says I have one last try, but that's only for these numbers, right? So now if I get it wrong again, is it 0? Okay, I'm wrong. Oh no. But that's attempt 1, and I can hit try another, right? And so now I'm on attempt 2 of 5, right? So how many attempts do I get altogether? Well, I get 3 tries on 5 attempts. So 3 times 5, I get 15 submissions, right? But that's not all. I can redo the assignment at the end and get another 15. So it's really up to your willpower how many times you're going to retry a problem, right? Okay. Any questions about this? All right. I got a request to enable some helps because they weren't there. So I enabled all of them. Explanation, right? What does this do? I'm going to lose an attempt if I ask for an explanation. So I hit OK. And it tells me exactly how to do the problem. And then I can return a question, but now I have to try another and lose an attempt, right? Does that make sense? Okay. Can I do a guided solution? It's going to take me step through step and ask me in between questions, which may be nice in some problems, maybe more confusing if you have a different way in mind how to solve it. So keep that in mind. Do you lose an attempt for that? Yeah, you lose an attempt for that. And example, it just changes the numbers for you, but shows you how to do it. Do you lose an attempt for that? No, because they're different numbers. Here's my concern. And in the past, I've disabled all of them. Because what a lot of students will do, I'm sure this is not you, they'll just notice, oh, if I just plug my numbers in there, and I do the same pattern, I can get the right answer without understanding how to do it at all. So just make sure if you get help, whether it be from someone else in office hours or the CLC, or from the homework system, you take the time to understand how to do the steps, because the test matters so much more. All right, any questions about this? So I'm just going to enable all the helps all quarter long, but for your own sake, use them as appropriate. And the goal is to be able to do the problems without any help eventually. Okay, I do see, since I did extend all the homeworks to be due on Monday, a lot of you started falling behind. Many of you are right on track. Please catch up with at least the last 2 assignments because math builds on itself, right? So if you didn't do last night's homework, then today, if we do complete and square, you might be a little bit lost. So make sure to keep up every night. I had another request to record the lectures and post it. Would that be helpful? Okay. But it's going to be like not like a fully edited video, okay? It's going to be like me asking questions and whatever. So feel free to fast forward or whatever through my mumbling. Okay, so record video. Are you still going to show up to class if I record these? Okay. If people stop showing up, I'm going to stop recording and posting. Okay, and then I need to somehow get you to try the homework the day that I lecture. Okay, so usually I have the homework due the next day. But if there's issues, it's hard to ask questions about it. So what if I come to class 10 minutes early to answer homework questions? And then I have homework due an hour after class. Is that okay? So then you can go to CLC for help the day of, or ask last minute questions before class. Okay, let's do that. That way you still try the homework before class, because you can't complete it all in 1 hour after class, right? Anything else I should go over? Oh yeah, so what that means is, don't kill yourself on the homework, right? Make sure you, if it's like really hard, then just ask some questions. Don't like bang your head on the wall for like 4 hours. And the main reason I'm doing all this is because last fall, my pass rate for college algebra was 45%. Yes. So I need to make sure everyone's keeping up, understanding everything as we go along. Okay, granted, it might be because we did not have placement exam. Oh. So people may have been taking it that weren't ready. Okay, now we have placement. I'm hoping that will make sure that you're all ready at the start. Okay, so 1.5, we're doing applications of quadratic equations. What is a quadratic equation? Do we recall? Well, there's an equal sign because it's an equation. Oh, in what form?
AX plus BX plus C.
Close. Oh, yes. That's what she meant though, right? Okay. If it can be put in this form, the main thing we're looking at is the square, right? The square tells us it's a quadratic, the variable squared. So word problems that will give us a square tend to have a multiplication or product of two variables, right? X times X is X squared. So here's some formulas we should be familiar with. Area of rectangle, length times width. They're both in terms of X, we'll get an X squared. The area of a circle, S squared. The area of a triangle, 1/2 base times height. The Pythagorean theorem. We have a right triangle, sides A squared plus B squared equals C squared. Or 1/2 base times height. The area of a circle. Looks like we're having all area and some volume problems. All right, let's try the first example. A trough at the end of a gutter spout is meant to direct water away from a house. The homeowners make a trough from a rectangular piece of aluminum that is 20 inches long and 12 inches wide. This diagram shows one metal sheet, 12 inches wide, 20 inches long. They make a fold along two long sides, a distance of X inches from the edge. So you can see that in the diagram also. We make a fold along the dotted lines, X inches from the edge. If they want the trough to hold 360 cubic inches of water, how far from the edge should they make the fold? Okay, so we're essentially going to fold these up and make a 3D shape. Can you imagine that shape? Yeah? Can we draw that shape? All right, let's say this is 20, the 20-inch side, and we fold it up. How high would these be? Very good, X inches, right? And how long would that be? Not quite. So this is a little bit tricky because I'm taking something away. We're getting closer. I heard, oh, we're getting so close now. There we go. I heard a right answer. Oh, very good. So this is side 12. We need to subtract an X here and subtract an X there. So this side is 12 minus 2X. Any questions about that? Okay. Now, how do we come up with the volume of a rectangular solid? Very good. So that wasn't one of my formulas, but I hope you do know this one. The volume of a rectangular solid is length times width times height. So what is my length? 20 inches. What is the width? 12 minus 2x. And the height is x. All right, so what gives it away? This is a quadratic equation. X is multiplied together to make an x squared. So can you guys distribute this in your head? Let's call this 20x. What's 20x times negative 2x? Huh? All right, I'm just going to do one at a time. What's x times negative 2x? And what's x times 12? All right, I still have the 20 to distribute. And we get, what's 20 times 12? Very good, 240x. And 20 times negative 2. Yeah, negative 40x squared. All right, so those of you that did the homework, this is just like nothing, right? You solved so many of these. How do you solve it? What's that? Sure, you can complete the square. Quadratic, and I'll give you a little hint that most of these application problems are factorable. So we will try that first, but yeah, we know that factoring doesn't always work. So maybe if you're really good at quadratic formula, you'd go with that first. Okay, so which side do you want to make 0? Sure, do that. It doesn't matter, right? I'm going to make the left side 0 so that I get a positive x squared. Okay, so on the left-hand side, I get 0, 40x squared minus 240x plus 360. Is there a common factor between all these numbers? They all have a 0, so 10. So what about 4, 24, and 36? They're all divisible by 4. So we can factor out 40. Get x squared. 24 divided by 4 is 6. And 36 divided by 4 was that 8? Okay, so can we factor this further? No, that's not 8. 9. So can we factor this further? Factors of 9 that add to make negative 6. Negative 3 and negative 3. So I have a product of 3 things that equal 0. Logically, we conclude what? One of them must be 0. Is 40 0? No. That one's obvious, right? When is x minus 3 equal 0? When x is 3. And same thing for this one, right? So x equals 3 is our answer. What was the question asking for? How far from the edge should we make the fold? So let's fold this 3 inches from the edges. Any questions about this? Yes.
Why did you write the 45? Like, I know it doesn't, but why?
In the future, we'll have multiple factors, not just 2. But like, you could have a cubic, and you could have, I'm gonna write this on the board. Maybe I shouldn't. If I'm recording. Yeah, zero product property works for more factors. I could have x plus 3, 2x, and x minus 5 equal to 0. And I know any of them could be 0. Because if I multiply by 0, it's 0, right? So I could set all of the factors equal to 0. 2x equals 0, x plus 3 equals 0, or x minus 5 is equal to 0. And I could get 3 solutions if I have 3 things multiplied together. So I could get x is 0, x is negative 3, or x is 5. So just to get in the habit of multiplying, checking if that's 0, I just asked, is that 0? You don't have to do that. Yeah. Okay. Any other questions? Let's try the next one. A box is to be formed by taking a sheet of cardboard and cutting away 4 2-inch by 2-inch squares from each corner. Can you imagine it? Then the sides are turned up to form a box that holds 56 cubic inches of air, I guess. If the length of the original piece of cardboard is 3 inches more than the width, find the dimensions of the original sheet of cardboard. So it would be a good idea to be able to translate that to this diagram. So each of these squares is 2 by 2. 2 inches by 2 inches. It said our sheet of paper is x inches by x plus 3 inches. Okay, and so my equation relating these is for what? Is it area? Volume, yeah. So cubic is volume. So I need a box. So if I folded this up, can you see what that would look like? Do I know the length, the width, or the height? Which one of those do I know? The height, very good. The height is what? 2 inches. Okay. So this will be a little bit tricky. What is the length? 2x plus 3 would be before I folded it up, right? I'm taking the x plus 3 and I'm folding this edge up and folding that edge up. So what should it be? Huh? What I'm really asking for is what is this size here, right? So it's not x plus 3, that's the entire thing. X plus 3 minus, very good, minus 2 on this side and minus 2 on this side. X plus 3 minus 4 is it's minus 1. All right, what about this side? Tell me that. Good. X minus 4 is correct. X, so I want this edge here, minus 2 here, and minus 2 there. X minus 4. That's probably the hard part, interpreting and saying up. But what's the equation we want? The volume of this box is 56 cubic inches. Our equation for volume, length times width times height. So what's my length? Good, x minus 1. What's the width? X minus 4, and the height? 2. What type of equation is this? Quadratic, because they're all quadratic, right? But we're multiplying an x in an x term. So what's the first step to solve this quadratic? Good. Let's go ahead and FOIL this out. What's x times x? X squared. What's x times negative 4? Negative 4x, negative 1 times x. Negative x, negative 1 times negative 4. Positive 4. And then we need to multiply the whole thing by 2 at the end. So x squared minus 5x plus 4. If we distribute the 2, we get 2x squared minus 10x plus 8. And we'll subtract the 56 from both sides. Pick your favorite method to solve a quadratic. We'll try factoring first, because these application problems tend to be solvable by factoring. What's 8 minus 56? Good, negative 48. Common factor of 2. Let's take out the 2. X squared minus 5x minus 24. Does it factor, or do I need to do quadratic formula? Okay, I heard 3 and 8. Is one of them negative? X plus 3, x minus 8. And we all just double check. Do they add to make negative 5 and multiply to make negative 24? Very good. So either 2 is 0, we don't need to write it, or x plus 3 is 0, or x minus 8 is 0. So what are my solutions? Negative 3 and 8. Do they both make sense? No. Why not? Yeah, I can't have a negative 3-inch paper. So what's the question asking for? Find the dimensions of the original sheet of cardboard. So the dimensions were x by x plus 3. So 8 by, and 8 plus 3 is 11. 8 inches by 11 inches is our final answer. Any questions about this? Example 3, a window is in the shape of a rectangle with an adjacent right triangle above it. The length of one leg of the right triangle is 2 feet less than the hypotenuse. the length of the other leg is 1 foot less than the length of the hypotenuse. So the trick here when setting this up is to ask what it's talking about. So it says than the hypotenuse, than the length of the hypotenuse. Whichever one it's talking about is usually your variable. So you pick that to be x or c. And that's what they did in the diagram. And so 2 feet less than the hypotenuse is x minus 2. 1 foot less than the hypotenuse is x minus 1. And the hypotenuse should always be the longest of the 3 sides. What type of equation can we set up here if we have the side of a right triangle? The Pythagorean theorem, which is what? Plus b squared is equal to c squared. And the label of which one's most important, A, B, or C? C is the longest side. If you label the other ones differently, it's okay, right? Because addition is commutative. Doesn't matter if it's a squared plus b squared or b squared plus a squared. But you better get that hypotenuse right, or the whole thing will be wrong. All right, so let's plug in. The hypotenuse is x. Let's square it. All right, what's a? Well, I said it doesn't matter. Typically, you make it the shorter side. It won't matter which one you pick, though, right? And leg B, x minus 1. All right, do we know how to solve this? All right, go ahead and solve it. Let's race. You solve it and I'll solve it. See who finishes first. All right, don't let me catch up. All right, were you guys able to get these two solutions?
Yes.
X equals 5, x equals 1. All right, so half the battle is doing these computations without making an error. And so we want to practice our homework in that manner. It happens, you know, but I will say I'd be a more effective teacher if I could make you do push-ups. Because when you make a mistake, it's not a big deal, but if you have to do push-ups after, you know, you're not gonna make the same mistake twice. So, all right, x is 5, x is 1. Do they both make sense? Heard no. Which one doesn't make sense? Why doesn't 1 make sense? It's a positive number. What? That's right. So one of the sides would be 0, right? 1 minus 1 would be 0, or 1 minus 2 would be -1. So for that reason, 1 doesn't make sense. So maybe I should write that. What are my side lengths? They are x minus 1, x minus 2. And for that reason, 1 doesn't make sense. So what are they? 5, 4 and 3, and I should include units. Feet. 5 feet, 4 feet, and 3 feet are the lengths of the sides. All right, any questions about that? Solving applications involving quadratic models. So a common, have you guys taken physics? Yeah. All right, are you used to projectile problems? So when I throw something in the air, what's the shape it makes? A parabola? Okay. And parabolas are quadratics. In particular, these are upside down, right? So the leading coefficient should be positive or negative? Negative, right? So we're going to have it negative. If you want to derive this formula from scratch, you should take calculus. But for now, we're going to memorize this formula. S represents position or displacement. How high is my object? What is the height? At a given time. Right? So at second 0, it's in my hand, height of, I don't know, 3 feet. At 1 second, it's up here. At 2 seconds, it's down there. 3 seconds, already hit the ground. So if I plug in a different time, I'll get a different height for this downward parabola. G is what's called the gravitational constant of acceleration. So we have a position, and then we have a velocity is the change of position over time. Acceleration is a change of velocity over time, which is the change of position over time squared. That confusing? Position is a height. So maybe we'd say feet or meters, right? Okay. Velocity would be change of position with respect to time. How fast is it going? Feet per second. And I said that acceleration is change of velocity over time. But velocity was feet per second, time per second is feet per second squared. It's a change of a change, right? So they tell me that the gravitational constant is 32 feet per second squared. You believe that? The acceleration is always the same?
Yeah.
So if I drop this pen and I drop my phone, they drop at the same rate?
Yeah.
I'm gonna drop my phone. Okay. So we believe that? Okay, and that's true. So this is acceleration, but it's only true under this scenario. It turns out there's another equation for gravity between two masses. Have you ever seen that equation in physics class? Okay, so it turns out this is not always true. It's true when one object is so massive that the change doesn't matter. So Earth is so massive that the difference between these two objects, gravitational pull between them, is negligible. So we assume it's constant. It's not really, right? Because this has a different mass than this. So technically speaking, they don't fall at the same exact speed. but the difference is so small that we say they do. So we're going to pretend that it's constant because it's a model. It's close enough. Okay, our equation, -1/2 times the gravitational constant times t squared plus, what's V naught? It is the initial velocity that I've thrown the marker with, right? If I throw it slower, it's going to be different than if I throw it faster. And then what's S naught? The initial vertical position. So it matters if I throw it from here or if I throw it off the top of a building, right? It's going to have a different path. Let's try a problem. A model rocket is shot straight upward from a launch pad of 1 meter above the ground level with initial velocity of 24 meters per second. Write a model to express the height of the rocket S in meters above the ground level. So we just need to plug in the right things into this formula. The formula S of t is equal to -1/2. So G, should I use 32 or 9.8? Okay, why am I using 9.8? Meters per second, we're going to use, what's that called? Metric system. 9.8 meters per second squared times t squared is our variable. Plus, do I know the initial velocity? Initial velocity is 24 meters per second. And because it's positive, that means it's being launched what direction? Upward. If it's negative, be launched downward. Okay, 24, our variable is t, so it stays there. Plus, do I know the initial position? It's launched from a height of 1 meter. If it was launched from the ground, we'd put 0. Okay. Any questions about this? So this is function notation. S of t tells me that t is the independent variable. Sometimes I just put s. That's fine also. Oh, that would be -4.9 t squared. 24t plus 1. Okay, so that's just plugging into our formula. Now, part B, find the times at which the rocket is at a height of 20 meters. Round to 1 decimal place. So this 20 meters is referring to what? A height of 20 meters. I have two variables. I have an S and I have a T. Which one is this referring to? S. Height is displacement. We're going to plug this in for S. 20 is equal to -4.9 t squared plus 24t plus 1. Why is this in this section? Another quadratic equation. How do we solve it? We usually make one side 0. Maybe let's make the other side 0. So we have a positive leading coefficient. Okay, so if I do this to both sides, what do I end up with? 4.9 t squared minus 24t and 20 minus 1 plus 19 is equal to 0. Probably not factorable. You want to do completing the square or quadratic formula? Do whichever, they both work. I'm going to use quadratic formula. 4.9 is A, -24 is B, and C is 19. Okay, so when we use this, we get t is equal to what? Negative b plus or minus, do we have it memorized now? B squared minus 4ac over 2a. Okay, so b, I'm writing negative 24 in green in two places. A, I'm writing in blue, 4.9 in two places. And C is 19, I'll write in red in one place. Any questions about this? So we got 24 plus or minus the square root of. What is the discriminant? It's all of that inside the radical. Did you plug in your calculator? What do you get? Will you make me pull out my calculator? Or who's making who? Let's see. All right, so what's 24 squared minus 4 times 4.9 times 19? 203.6, is that what you got? 203.6. All right, all over 9.8. All right, anyway, we should get 2 times. These 2 times should be t is approximately equal to 1.0 and t is approximately equal to 3.9. If you plug those both into your calculators. Do those both make sense? Can I get 2 answers to this type of word problem? I heard yes. You agree? So I launch a rocket from 1 meter up.
Wait.
No.
After 1 second, maybe it reaches that. And on the way back down, maybe after 3.9, it reaches that. Sure, I can get it. Right? At 2 different times, it could reach the same height. Right? So I can get 2 answers. Could I get 1 answer? Right there only, right? Or I guess right here, that would be really tricky. To give you 2, you have to know throw that one out. It would be negative time before I threw it. All right, 2 answers make sense. If I'm launching a rocket, it has to go up and come back down. Part C, find the times at which the rocket reaches a height of 40 meters. How is this different from part B? Do I plug in the time? No. The height is 40. It's asking for the time, so that's the unknown. S equals 40. So it's essentially the same problem, right? Negative 4.9 t squared plus 24t plus 1 is equal to 40. So same setup. Why are they making me do this twice? Let's add 49 t squared, 4.9 t squared to both sides. Let's subtract 24t from both sides. And let's subtract 1 from both sides. Let's do the quadratic formula. T is equal to 24 plus or minus the square root of 24 squared again. Should be negative, but it's in parentheses. Minus 4 times 4.9 times 39 over 2 times 4.9. So I get 24 plus or minus the square root of something over 9.8. What is the discriminant? Okay, what's 24 squared minus 4 times? Oh no, I messed up. Oh gosh, I hate calculators. 24 squared minus 4 times 4.9 times 39 equals negative 188.4. What can you tell me if the discriminant's negative? No, that's if the, well, we're solving for time. So negative time would mean something else. What? What's the square root of a negative number? It's imaginary. So it tells me I'm gonna get two complex, non-real times. What does that mean? It doesn't reach 40 feet. It's gonna top out before then. It's not gonna reach 40 feet. So we're gonna get two complex, non-real times, which implies the rocket does not reach 40 meters.